So welcome to EasyTech Masters online series, and today we are here, that is basic electrical and electronics engineering, and the topic is the problems on transformer. So let us see some problems on transformer with solutions also. Yeah, this is the first problem. Yeah, what he has given, in the sense he has given the data like this. Yeah, a 40 kVA, this is the transformer rating, 3300 by 4 240 volts. That means he has given the transformer rating as that is kVA rating. That means this will be equal to 40. And what is this 40? In the sense, it is equivalent to the V1 I1 as well as V2 I2. This is equal to 40 kVA, and that means 40 into 10 power 10 cube, 40 10 cube VA. This is the first information he has given from this 40k, and he says that 3300 volts and by 240 volts. That means this is V1 and this will be V2. V1 V2 also given. And next one is single phase, that is 50 Hz frequency is given. The transformer has 660 turns on primary. N1 is given. Then determine the number of turns on the secondary, maximum value of the flux in the core, and the last one is the approximate value of primary and secondary full load currents. So this is the problem he has given and he asked. Then we know what are the values he has given. Yes, after identifying the values what he has given, then we'll go with the equations, what we know, and how we can substitute all these values in that equation. Then how we can find out the 1, 2 and 3 sums. Yes, let us see that. Yeah, the first one, what he asked, in the sense, the number of turns on the secondary. That means once you know V1 and V2, V2 is equal to 240 volts. Once you know these two values, then you can find out transformation ratio K. K is equal to V2 by V1. Yes, here V2 is 240 divided by 3300. 0 get cancelled. Then what is this value, in the sense? Yeah, 24 divided by 330. This will be 0.0727, and we know that this K value is equal to N2 by N1 also. So by using this relation, you can able to find out the number of turns on the secondary, as is N2 by N1 is equal to K. This will be is equal to 0.0727. Then what about N2? N2 is equal to 0.0727 N1. Yes, N1 value already has given. That value is 660. Yes, that is 0.0727 into 660. Then this will be 47.98. Generally there is no points for the number of turns, so hence we can simplify this as nearly 48 because it is 47.98. The first thing we got. The next second one is the maximum value of flux in the core. Maximum value of flux in the core, in the sense you know the EMF equation of the transformer. Yeah, what is the EMF equation? Yeah, EMF equation is E is equal to 4.44 pi m f n. If it is E1, this will be N1. If it is E2, this will be N2. And generally, as he said, approximate values are there, and he did not specify any resistance which is present in the transformer. Therefore, we can equal to either V1 or V2. Yes, if I take V1, then I can take N1. If I take V2, then I can take N2. So hence V1, that means 3300 is equal to 4.44 pi m. You need to find. F is 50 and N1 is 660. So hence what is the value of pi m? Yes, what is the value of pi m? If you see this, 3300 divided by 4.44 into 50 into 660. Yeah, the answer will be 0.0225. Or you can also, this is Webers, or you can also write 22.5 Webers. 22.5 milliwebers. Sorry, milliwebers. The second problem is also over. Next, what is the third one? The approximate value of primary and secondary full load currents. Yes, what about how you can find out this one? Just to remember the first formula I have given, that is 40 kVA. In the sense, you can write that as V1 that is V1 I1 is equal to V2 I2 is equal to 40 into 10 cube. So you need to find out what is I1, what is I2. Therefore I1 is equal to 40,000 divided by V1. Then what is this value? 3300. Then this value will be 3300. 12.12 amperes. And similarly, what is the value of I2? We know that I2 is equal to, yes, I2 is equal to 40,000 divided by V2. Yes, 1000 divided by V2, in the sense 240. Then how much this value, in the sense, yeah, this will be 166.67 amperes. This is how we can able to solve the first problem. Okay, and we'll see one another problem. The problem is like this. That means here also he has given V1 and this will be V2 and 50 Hz frequency is there, has an approximate EMF per turn, that is E by N is equal to 15. maximum flux density. Flux, okay, flux is given, but here the units of flux is Tesla. Tesla is the unit of Weber per meter square. That is flux density B, which is equal to pi by A. Then calculate number of primary and secondary turns, and the second one is cross sectional area of the core. Now how you can find out this one? Yeah, in the place of V1, E1, you can place V1, that is V1 by N1 is equal to 50. That means how much this value? N1 is equal to V1 by 15, 4500 by 50. Now how much N1 value? 4500 by 15. This value is 300 turns. This is turns. And similarly, what about second case? V2 by N2 is equal to 15 here also. Then N2 is equal to V2 by 15. So where V2 is 225 ohms. If you do that one, 225 by 15. How much value will get? It is 15 only. The first problem is over. Then how you can find out the cross sectional area of the core? That is, you need to find the value of cross sectional area. So for that, we know the B value. B is equal to pi m by A, and pi m in the sense B into A. Yeah. So therefore, first we remember the EMF equation. E1 is equal to V1 is equal to 4.44 pi m F N1. Then in the place of pi m I can replace with BA. Then A is equal to V1 by 4.44 B F N1. Now you substitute all this value. V1 in the sense 4500 divided by 4.44 into B value. B value in the sense 1.4, frequency is 50 Hz, N1. Yes, what is the value of N1? N1 in the sense I think 300. Yes, now how much this value? A is equal to 0.04826 meter square. The second is also over. Next, let us receive another problem. Yeah, this is very simple problem. Yes, what is the value she has given? V1 is there, V2 is there. V1, V2, and this value is V1, I1, V2, I2, and N2 is there. N2 is equal to 66. Then what is primary turns? Primary turns in the sense immediately we will go with V2 by V1 is equal to K. That means K is equal to 200 by 2000. Then what is this value? 2 by 20, 0.1. Then what is n1? And you know that n2 by n1 is equal to k. Then n1 is equal to n2 by k. That's where n2 is 66 and k value is 0.1. Then what is n1? 66 by 0.1, which gives 660 tons. Then what about primary and secondary full load currents? We will use this equation. As if you use that equation, you will get I1 is equal to, yes, V1 I1 is equal to 20,000 divided by 2000. This will be 10 amperes. And similarly I2 is equal to first kVA, 20,000 divided by 200. Then this will be 100 amperes. Yes, this is how you can solve this problem. Let us see another problem. Yeah, this is also very simple. He has given frequency and he said it is single phase transformer and V1 is there, V2 is there, having EMF per turn, that is V by N is equal to 10. Then maximum flux density in the core is 1.6 Tesla. Already we have done the same kind of problem. This B max is equal to 1.6 Tesla. Find the suitable number of primary and secondary turns, cross-sectional area of the core. So how you can find out? Yes, first immediately what we can do in this sense, what is the value of transformation ratio? K is equal to 400 by 6600. How much this value? 4 by 66, 0.0606. And he said V1 by N1 is equal to 10. That means what is N1? V1 by 10, where V1 is 6 by 10. So then how much it is? 660. And similarly, what is N2? N2 is equal to V2 by 10. V2 is 400 by 10. This will be 40. So how many number of turns are there in the primary? 660. How many number of turns are there in the secondary? 40. Yes, very good. This first bit is over. Then what is the second one? Cross-sectional area of the core. Yes, how we can find the cross-sectional area as we found in the previous problems? That is EMF equation. E is equal to 4.44 pi m f n. If it is E1, this will be n. Yes, now we find. Yes, we know that n1 is 660, E1 is 6600, then 4.44 pi m is B into A, F into 660. Now find out what is A. A is equal to 6600 divided by 4.44, and here what is B? 1.6 into frequency is 50. 650. So then 660. Now how much this value? So let me type in the calculator. 1600 divided by 4.44 into 1.6 into 50 into 660. Yeah, this will be 0.0281 meter square. Okay, yeah, this is how we can solve this problem. Let us receive one more problem. See here, this is also single phase core type 50H transformer, has a square having 25 centimeter square. Square in the sense indirectly has given A. A is equal to 25 into 25. Yes, so how much this value? 625 centimeter square. If you want to convert to the meter, then it will be 625 into 10 power minus 4 meter square. This one. The maximum flux density in the core is 1.2. That means Bm is equal to 1.2 Weber per meter square. Then you need to find number of turns per limb on HV side and LV side. That means you need to find N1 and N2. N1 and N2. Yes, how you can find out this one? Yeah, tell me how we can find out this one. V1, V2 also is there. V1 is 3400 volts and V2 is 240 volts. Yes, first let us find what is K, transformation ratio K. K is equal to V2 by V1. This will be 240 by 3400. 240 by 3400. How much is this value? This is about 0.07059. Yes, once you know this value, then you can easily find out what is N1, what is N2, like this. Okay, and he said pi you can find out. Yes, that is, you can write the value of V1 as V1 is equal to 3400 is equal to 4.44 pi m. Pi m in the sense Bm into A, Bm into A, F into N1. Therefore, N1 is equal to 3400 divided by 4.44 pi m, Bm, Bm, A, F. Yes, you can substitute all these values. That is 3400 divided by 4.44 into Bm value is 1.2 into next cross sectional area 25 into 25 into 10 power minus 4 yes, divided into frequency. So hence how much this value? This is about 204.2, or you can also write nearly 204 tons. 204 tons. Now you need to find out LV side also. LV in the sense low voltage, HV in the sense high voltage. Yeah, in the same process, if you do that one, that is V2 is equal to 4.44 pi m f into n2, where in the place of pi m we can substitute b into a. Okay, so then 240 is equal to 4.44 into bm value is 1.2 and a value is 625 into 10 power minus 4 into 50 into n2. Now find out the value of n2 here. Yes, n2 is equal to 240 divided by 4.44 into 1.2 into 50 into 625. Then how much answer? This answer will be 14.41 or simply 14 tons. This is how you can solve the problems in the transformer. Thank you for watching this. So don't forget to subscribe this channel and click on the bell icon to get the notification. Yes, thank you once again.